In this lesson, we will learn how to plot a physics graph step by step. I will show you how to plot decimals, draw the line of best fit, find the slope, and analyze the graph. For our example, we will use data from the West African Senior School Certificate Examination 2018 Physics Practical on simple pendulum. So, in the practical, this is the setup, and this is the length of the strength of the pendulum. So on the table we have the length in meters, and this is the time for 20 oscillations. That is time 1 in seconds. And this is another time for 20 oscillations. That is time 2 in seconds. And this is the mean time, which is time 1 plus time 2, and the result divided by 2. This is the period in seconds. The period is the time taken for one complete oscillation. So that is the mean time divided by 20. And we have the square root of the length. And we are going to plot a graph with t on the vertical axis and root L on the horizontal axis. So now, for the values of t, the first value is 1.92. And to plot 1.92 directly on the graph is going to be challenging. So we are going to move the decimal point 1, 2 to the right and record this as 192 times 10 exponent negative 2, and the unit is seconds, times 10 exponent negative 2, because we move the point twice to the right. So the next one, 1.79, we are going to move this point 1, 2 to the right, and we have 179. So the next one will be 168, the next one 155, and 142. For the values of root L, we have the first value to be 0.949, which is also going to be challenging to plot directly on the graph. So we are going to move the decimal point 1, 2, 3 to the right and record this as 949 times 10 exponent negative 3, because we moved it 3 times to the right, and the unit is meters exponent 1/2. The next value, when we move this point 1, 2, 3, we have 894. The next one will be 837. The next one 775, and the last one is 707. So we just want to see the values as whole numbers for easy plotting. That's why we adjusted them to standard form. So we are going to plot these values on the graph. So we draw the vertical and horizontal axis. And we are plotting t on the vertical axis. So we have t slash 10 exponent negative 2, and the unit is seconds, meaning we have converted the period to standard form by shifting the decimal point twice to the right for the values to look like whole numbers. And we are also plotting root L on the horizontal axis. So we have root L. Also, we have shifted the point 3 times to the right. So we have slash 10 exponent negative 3. And the unit is meters exponent half. And we are going to choose a scale for the graph. Looking at the values of the period, the least value is 140, and we've not been told to start from the origin, so we can start from 140, and we are going to choose a scale of 2 centimeters is to 5 times 10 is to negative 2 seconds on t-axis. So we start from 140 and we add 5. So 145, keep on adding 5, 150, 155, 160, and so on. And for root L axis, we can start from 700 since the least value is 707. And we choose a scale of 2 centimeters is to 30 times 10 exponent negative 3 meters exponent half on root L axis. So we are going to add 30 to 700. We have 730. We add another 30, 760. We keep on adding 30. So on the vertical axis, the distance between each big box is 5. And 5 divided by 10 is 0.5. So each small box on the vertical axis is going to be 0.5, meaning 2 boxes on the vertical axis is equal to 1. And on the horizontal axis, the distance is 30. 30 divided by 10 is 3. So each small box on the horizontal axis is going to be 3. So this is going to guide us to plot the graph. The first point we have 192 on the vertical axis. 192. This is 190 and 2 boxes is equal to 1. So we count 4 more boxes after 190. And 949, this is 940. 1 box is 3. So 943, 946. 949. So 940 plus 3 more boxes. And they are going to meet here. The next one we have 179. So this is 175. 2 boxes is equal to 1. So we count 8 more boxes to get 4 added to the 175, making 179. And 894. This is 880. 1 box is 3. So 1 box will be 883, another one 886, another one 889, and the fourth one will be 892, and 894 will be in the next box. So they are going to meet here. 168, this is 165, plus 2 boxes is equal to 1. So we'll add 6 more boxes. So 165 plus 6 more boxes will give us 168. And we have 837 on root L axis. This is 820. And 1 box is equal to 3. So 823, 26, 29, 832, 35, and 37 will be within the next box. So they are going to meet here. The next one, 155 is here. We have 155 here and 775. This is 760. The middle is going to be 775 because we have 30 divided by 2, which is 15, added to 760 will give us 775. So they are going to meet here. The last point we have 142. This is 140. We want 2, so we move 4 times. Since 2 boxes is equal to 1. 707 on root L axis. This is 700, 703, 706, and 707 would be within the next box, so they are going to meet here. And we draw the line of best fit. Determine the slope S of the graph. So we draw these horizontal and vertical lines. These lines can be drawn at any point. There is no specific point to draw this line. But make sure the slope is as big as possible. We name here A, here B, and here C. The slope is change in BC over change in AB. For change in BC, that will be C minus B. So to get C, we draw this line and we have 183 minus B, which is 150. Remember, times 10 exponent negative 2 on the vertical axis, and the unit is seconds. And for AB, we have B minus A. B is 910 minus A is at the middle of 730 and 760. So we'll add 15 to 730, which gives 745 times 10 exponent negative 3, and the unit is meters exponent half. So 183 minus 150 is 33 times 10 exponent negative 2, and the unit is seconds. 910 minus 745 is 165 times 10 exponent negative 3, units meters exponent half. And 33 times 10 exponent negative 2 is 0.33. The unit is seconds. 165 times 10 exponent negative 3 is 0.165. And we add the unit. And now 0.33 divided by 0.165 is 2. We have seconds at the numerator and meters exponent half at the denominator. So the reciprocal of meters exponent half will be meters exponent negative half. So this is the slope. Evaluate G is equal to 4 pi squared divided by the slope squared. So we have G is equal to 4 pi squared over S squared, where S is the slope. But pi is a constant, 3.142, and the slope is also 2 seconds per meters exponent negative half. So we replace them. And 4 times 3.142 squared is 39.49. 2 squared is 4. And the square will also affect the units, seconds. So we have second square. The square will also multiply negative 1 over 2, which gives negative 1. So we will have meters exponent negative 1 over here. And 39.49 divided by 4 is 9.87. The reciprocal of per meters is meters, since per meters is at the denominator. And we have second square at the denominator, so the reciprocal will be per second square. So G is equal to 9.87 meters per second square, which represents acceleration due to gravity. Now B part of the question. I. Determine from your graph the period of the pendulum for L is equal to 75 centimeters. So now the length of the string is 75 centimeters. We change it to meters by dividing by 100, which gives 0.75 meters. And remember, we plotted square root of the length. So let's find root L. That will be root of 0.75 meters. Square root of 0.75 is 0.866. Then we have meters exponent half. And remember, on the horizontal axis, we changed it to standard form by moving the decimal point 1, 2, 3 to the right. So we have 866 times 10 exponent negative 3, and the unit is meters exponent half. So we can draw a line on the horizontal axis at 866. So this is 850. One box on the horizontal axis is 3. So 853, 56, 59, 862, 65, and 66 will be in the next box. And we connect it to the period axis, and read the value over there. So from the graph, when L is equal to 75 centimeters, the period is 174. Remember, times 10 exponent negative 2 seconds on the vertical axis. Now 174 times 10 exponent negative 2 is 1.74, and the unit is seconds. If the length of the string is 75 centimeters, the period will be 1.74 seconds.